Good evening, everyone. Welcome to York Observatory YouTube, or as we like to call it, TeleTube, the online astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. My name is Dr. Elena Hyde, and I am here tonight to introduce to you our wonderful presenters from the Allan I Carswell Astronomical Observatory at York University. Tonight's presentation will feature Gagan, Aria, Gianluigi, Sana, and Quentin. So without further ado, I am going to go ahead and hand this presentation over to our wonderful students. Take it away.
Hi everyone, today we'll be giving you a crash course on backyard and armchair astronomy and sharing with you a bunch of interesting resources you can use at home to get the most out of stargazing. To start, I'll be showing you the basics of how astronomers organize the sky and celestial objects. To keep track of celestial objects, we use a bunch of different naming conventions based on different catalogs. These catalogs help when astronomers discover things in the sky and provide an effective way to keep track of them. The two main catalogs that we refer to regularly are the New General Catalog and the Messier list. The New General Catalog, abbreviated NGC, is an extensive catalog of deep sky celestial objects. It was compiled in 1888 by John Louis Emile Dreyer and built upon the cataloging work done by William and Caroline Herschel. It includes over 7,800 objects, including nebulae, galaxies, and clusters, and we commonly refer to objects by their NGC designation. NGC followed by the object's number. Pictured on the right is NGC 3031, also known as Bode's Galaxy or Messier 81. On the left is NGC 6611, the Eagle Nebula, or Messier 16. There is some overlap between different catalogs, and so some objects like these will have multiple designations. Dreyer also published two additional catalogs called the Index Catalogs. They list over 5,000 more objects which are given the designation IC, but we don't use this catalog as often. The Messier list is a much smaller catalog of deep sky objects. It includes 110 objects and was compiled in 1771 by Charles Messier. The funny thing about this list is that Charles Messier created it as a list of objects he meant to avoid at all costs. See, Messier was interested in observing comets, and back in the day, these dim, distant objects that looked like comets until closer inspection were foiling his research. He decided to put all of these objects in a directory so he'd know not to direct his attention to them. In doing so, he inadvertently created a list of 110 of the most interesting celestial objects in the sky, a list that astronomers now regularly consult. Designation for a Messier object is M, or Messier, followed by the object number on the list. Mapping the sky is also an important part of stargazing and observing, and learning how astronomers keep track of locations in the sky is a great place to start. The entire sky is divided into 88 constellations. While each constellation has a few main stars that are usually recognizable by shape, such as the distinctive bowl of the Big Dipper, constellations themselves are actually sections of the sky that astronomers use to better keep track of objects and locations. The image on the bottom left from the Stellarium computer program shows a section of the sky with the constellation boundaries highlighted in red. The celestial sphere, what we call the whole sky as seen from Earth, is mapped in a similar way to locations on the Earth. Objects on the celestial sphere are given coordinates with a right ascension and declination, which are equivalent to longitude and latitude respectively. Locations in the sky are measured in terms of degrees. The entire sky is divided into 360 degrees, with each degree containing 60 arc minutes and each arc minute containing 60 arc seconds. Declination of an object is noted as degrees, arc minutes, and arc seconds away from the celestial equator, with locations north of the equator noted with a plus and locations south of the equator noted with a minus. The image on the bottom is a handy guide to measuring degrees in the sky. Right ascension is noted slightly differently. The sky is divided into 24 hours, with each hour equivalent to 15 degrees. Each hour contains 60 minutes of right ascension, with 1 minute of RA equivalent to 15 arc minutes. Each minute contains 60 seconds of RA, with 1 second of RA equivalent to 15 arc seconds. Interactive sky maps such as Stellarium or other apps will list the location of a star or object using its celestial coordinates, REN declination, as such. Other stargazing guides sometimes define stellar locations in terms of degrees away from each other known stars, which can be easier to use when stargazing with the naked eye. For example, the Big Dipper, shown for scale on the bottom right, is approximately 25 degrees across, and you can measure it with your hand.
Now, I'll be giving you guys a review of a bunch of awesome objects that you can see on a clear night. So let's start with the stars. A star is a fixed luminous point on the night sky, which is a large, remote, incandescent body like our sun. Away from the light pollution of the city, stars are to be found everywhere in the sky. But surprisingly, there are more planets than there are stars in our universe. Now, planets. Planet is a celestial body distinguished from the fixed stars by having its apparent motion of its own. In terms of finding planets with naked eye, we could only observe the planets in our solar system, such as Jupiter for now early in the morning, and Mercury around sunset. Now on to the moons. Moon is defined to be a celestial object that makes an orbit around a planet, including 8 major planets, dwarf planets, minor planets. Like our own planet, Earth, we have one moon. Mars has 2, and unfortunately Mercury has none. Now, for the star clusters. Star clusters are a group of stars which are gravitationally bound. Two distinct types of star cluster can be distinguished. Globular clusters are a tight group of hundreds of thousands of very old stars, while open clusters are generally contain less than a few hundred members and are often very young. As you can see, we have beautiful pictures of star cluster here taken by our 1-meter telescope at Allan I Carswell Observatory. Now for the final object that we can locate on our naked eye, meteor showers. A meteor shower is a celestial event in which a number of meteors are observed to radiate or originate from one point in the sky. These meteors are caused by streams of cosmic debris called meteoroids entering Earth's atmosphere at an extremely high speed on parallel trajectories. There is a very likely chance that we're going to have a meteor shower on June 27th. Now, for the deep sky object, galaxies and nebulae. For the deep sky objects, we have galaxies and nebulae. Starting with galaxies, in terms of what is a galaxy, we can say a system of millions or billions of stars together with the gas and dust, held together by a gravitational attraction. For the month of June, we have Messier 106, a spiral galaxy up in the sky around 8 p.m. And here's a beautiful picture taken by our 1-meter telescope of Messier 106. Now, to my favorite deep sky object, nebula. Nebula is a cloud of gas either in outer space, visible in the night sky either as an indistinct bright patch or a dark silhouette against other luminous matter. For now, we have Orion Nebula up in the sky around 11 a.m. And this is a picture of Orion Nebula was taken by our 1-meter telescope as well. Here we have an amazing video of the International Space Station and Demo-2 craft passing in the sky, taken by Arsana, one of our observatory members. The Demo-2 craft recently carried 2 NASA astronauts to the International Space Station on May 30th, propelled by SpaceX's Falcon 9. Visit spot.the-station.nasa.gov to see when the ISS will pass over your area. NASA records ISS flybys all around the world, and you can input your location to find the best viewing times for you. When looking at the sky, the ISS looks like a really bright star, except that it moves pretty quickly. You can travel across the night sky in about 6 minutes.
Now that you're well informed on how the night sky is divided and what can be observed, here are some tips and tricks to help you while stargazing and your journey to become an amateur astronomer. Number 1, assure an optimal weather. It might be redundant to remember this, but do check the weathercast. Not only you want to make sure it's not cloudy and raining, but that there is no full moon as its luminosity is blocking nearby objects, making observation hard and tiring. We advise you pick a night when there is a new moon and get your eyes used to darkness, which usually takes about 20 minutes, which help to identify dimmer objects. Number two, getting acquainted with the night sky. Every amateur astronomer nowadays knows the resourcefulness of having in their phone an app that gives you access to a map of the night sky. Stellarium is a free mobile app that allows you to identify several celestial objects, like constellations, planets, satellites, in real time by just pointing your phone at the sky. This is an easy and fun way to learn celestial objects and master your ability in navigating across the night sky. Of course, if you're an old style, you can always try to make your own stellar map to keep with you at any time. Actually, Quinton will be doing a demonstration on how to make a star wheel later in the presentation. Number three, hunting planets. During the year, it is possible to observe some of the brightest planets like Mercury, Venus, Mars, Jupiter, and Saturn. But how can you identify them apart from stars but just staring at the night sky? Simple. Planets do not twinkle. Despite both appearing as dots of light, because stars are so far away, their beam of light is more affected once passing through our atmosphere than the beam of light of one of our closest planets. Also, all 5 planets have different colors. Mercury is about whitish color, Venus as well, but pretty bright, being the third brightest object as seen from Earth. Mars is a rust orange color. Jupiter is a tan color, and Saturn is about a yellowish tan color. Now take a second to enjoy some images we took with our 40 centimeter of Jupiter and Saturn. Number 4, meteors everywhere. Meteor showers, or popularly known as falling stars, happen almost every month. However, they can be observed at different times of the day and week depending where you live. And you might want to check first from which hemisphere the meteor shower will be mostly visible, what day and time zone the peak will happen. It is worth checking the website Earth Sky Guide to Meteor Shower 2020 or other sources. While observing for meteor showers, we want to ensure that you don't just focus on their radiant point, that is the area of the sky, usually a constellation, where they're radiating. Sometimes you might be able to see meteors before a radiant point is even above the horizon. Remember, these are only predictions, so we suggest you spend a bit more time while observing. Furthermore, it's not a typical rain, and you might be likely to observe a meteor every 5 minutes. Patience is the key, so you might want to get comfortable. For example, the Perseids, visible from the north hemisphere with a peak in early August with about 60 meters per hour, they radiate from the constellation of Perseus, and they tend to strengthen in number approaching midnight. And lastly, the moon. You need to be in an area where there's less light pollution to fully admire this event. Number 5, invest in binoculars. We get it. People get overexcited in starting this journey with a telescope. But if you feel you spend too much nights under the stars, it is time to buy a binocular and not a telescope. If you're not familiar with a telescope, it might be confusing at first, and eventually you're put off as not only you're learning how to navigate the sky, but also learn a fairly complex equipment. You don't even need to buy an expensive one. A decent binocular, a 7x50, allows you to admire 7 times as much info to your naked eye. I recommend one with the polar prism, as generally most suited to astronomy. These have larger lenses and tend to have better brightness and minimizing the shaking of ends. We suggest that you start with easy objects like the moon, planets, and eventually dimmer objects. One of my favorites, the Pleiades. It's one of the 3 open star clusters that are visible from naked eye from Earth. Lastly, just a final recap. Anyone can be an amateur astronomer, but starting and mastering the practice of stargazing takes time. You will find the weather is not always on your side, so you might have to try to observe the sky on different nights. It might take time to familiarize with the night sky and all its wonder, so relax and focus on a few easy objects at first. I always recommend finding the North Star as a beginner. Once you find the Big Dipper, you use the distance between the 2 outermost stars in the ball and place it about 5 times, starting from the inner star of these 2. This distance should take you approximately to a decent bright star, Polaris, which you can notice is also the tip of the handle of the Little Dipper. If you happen to living at high altitudes, like in Canada, the Big Dipper is a circumpolar constellation, which means it's always above the horizon over the year. Lastly, if you do not have a backyard or it's in the middle of a very light polluted area, you can always opt for a day trip camping. As a star watcher, darkness is your best friend and patient. Unless you're dedicated your night observing on the lunar surface, I apologize for our moon span, but our natural satellite is too bright for an optimal stargazing night.
How about ways to do astronomy without even going outside? There is a wealth of online resources available for free that will allow you to stay involved in astronomy. You can learn more through various ebooks, apps, podcasts, radio shows, and videos and live streams available online. And there are also ways to get hands-on experience without even leaving your home. NASA and many astronomy-based news websites have many free ebook downloads available on their website. Ebooks available from NASA focus on various fields of astronomy, as well as their missions and activities, such as a series about the Hubble Space Telescope, series about the Cassini mission to Saturn, experiments on the International Space Station, and many more. NASA also has many applications, including the virtual and augmented reality apps that will allow you to explore the universe. One of my favorite NASA apps is NASA's Eyes, and some screenshots of the app are shown on the right of the slide. This app allows you to explore not only the planets, moons, asteroids, and comets in our solar system, but also various missions and satellites, such as the Voyager spacecraft or the New Horizons spacecraft. The app also allows you to explore the Earth and our stellar neighborhood, including exoplanets, either through guided tours or just on your own. NASA also runs many different podcasts that are hosted by their own scientists and engineers. They cover a range of topics such as astronomy news, what's up in the sky, space exploration, and many more. Additionally, the radio station Astronomy.fm broadcasts 24/7 astronomy programs, including our very own broadcast of York Universe that plays every Monday night at 9 p.m. The radio show discusses the history and news of astronomy and runs in concert with our online public viewing, where you can chat about astronomy and check out some more images taken at the observatory. Make sure you join us on Mondays. Many astronomy videos and live talks are also available through NASA and other universities and organizations. For example, the Toronto chapter of the Royal Astronomical Society of Canada hosts speaker series, including The Insider's Guide to the Galaxy, which is an introductory course to astronomy and broadcasts on Tuesdays at 3:30 p.m. Additionally, NASA broadcasts a variety of different programs through NASA TV, available on their website. These programs include live streams of discussions and Q&A sessions that astronauts aboard the International Space Station frequently host, as well as other astronomy-related videos. Another cool thing that's shown on NASA TV is live streams of various events, such as spacecraft launches and their subsequent journey to the International Space Station. The journey of the Crew Dragon Demo 2 spacecraft was broadcast on NASA TV all the way from its launch on May 30th to its docking with the ISS on May 31st. This broadcast included how the astronauts were preparing for this historic mission. NASA TV, along with other places on their website, also have a continuous live feed of the Earth as seen from the International Space Station. NASA and other websites such as SLU will also host live streams of astronomical events such as meteor showers, planetary conjunctions, eclipses, and many more. One event coming up is the annular solar eclipse on June 21st that SLU will be live streaming from their YouTube channel. Make sure to leave the name of your favorite astronomy app, podcast, or channel in the comment section. You can also get hands-on involvement with astronomy from home. One way is through citizen science, where you can analyze real data to help professional astronomers make discoveries. There are many different citizen science projects that are available to everyone. Some of the examples are Gravity Spy, where you can help train computers by classifying glitches in data from LIGO, the Laser Interferometer Gravitational Wave Observatory. This will help physicists to identify gravitational waves generated during events like black hole or neutron star mergers, and is a fairly relatively new kind of physics that we can do. There's Galaxy Zoo, where you can classify distant galaxies based on their shape, which will help astronomers learn more about how they work and interact with their environments. Hubble Asteroid Hunter, where you can look for asteroids in images taken with the Hubble Space Telescope. And Exoplanet Hunters, where you can identify planets that orbit other stars by analyzing data from the Kepler Space Telescope. You can participate in these projects and many more by visiting NASA's website or by going to zooniverse.org or spacehack.org. Finally, another way you can get involved is by using remote telescopes, like the Micro Observatory, which is operated by NASA and the Harvard-Smithsonian Center for Astrophysics. You can request images of various celestial objects from planets to galaxies, and one of their 15-centimeter telescopes will image it and email the images to you within 48 hours, all for free. If you're interested in processing images, many of NASA's observatories encourage you to download raw data from their websites for processing and then share your final images with them. You can download data from the Hubble Space Telescope through the Hubble Legacy Archive to create your own images of your favorite celestial objects. Images taken from orbiters and rovers of Mars, Jupiter, Saturn, the Moon, and even Pluto are all available for free download from the appropriate mission pages on NASA's website.
A planisphere is a simple handheld device that can be used to map the sky for a certain date and time. And today, Quinton will be showing you how you can make your own in a recorded tutorial.
Provided to inthesky.org to access them. Special thanks to Dominic Ford for creating these templates. The planisphere consists of three basic parts: the holder, the star wheel, and the alt-as grid. For best results, we recommend you print the folder and star wheel onto thin cardstock, but if this isn't an option, then regular paper will do as well. This particular planisphere is designed for people living around a latitude of 45 degrees north, but templates for other latitudes are also available. As you can see, I've printed my alt-as grid onto acetate film, so it's transparent. If this isn't an option for you, you can feel free to skip the grid entirely. Aside from the printable templates, all you will need to make this device is a pair of scissors, a split pin fastener, and some glue if you want to include the grid. So step one is just to cut out the templates. That includes removing the gray oval here at the top of the holder. All right, so once that's done, you're going to want to cut out the small circle you see in the center of the star wheel, at the bottom of the planisphere holder, and just below the center of the grid. Okay, so you can see that I've just kind of punctured the hole with a pin. That's fine. I should be able to get the fastener through that later. So if you printed out the grid, you can glue it to the inside of the holder now. You're going to want to make sure that the four labels that say glue here are lined up with the cardinal directions on the window. So north, east, south, west. And you're going to want to stick it on the inside so that those four markings line up with them. Once the glue is dry, you'll have a nice window marked with a grid. So you can thread the fastener through that hole that you cut into the plastic, like so. And then you're going to want to thread the fastener through the star wheel, through the hole in the center, like so. And that should be able to rotate around. So now that you've got the star wheel visible through this window, you're going to want to carefully fold along the line here. You're going to want to fold that over. So now you can see the wheel is sandwiched inside the holder. And the last thing you're going to need to do is thread the fastener through the hole that used to be at the bottom of the holder. So like that. And then you can just fold it down, and that'll keep it sealed. So now you can rotate it around. And voila, it's finished. So all the stars that you see within the window represent all the stars that would be visible at a certain date and time. So let's say I wanted to use this at midnight on June 3rd, for instance. Midnight is represented here on the rotary. So you see this 11 p.m., 1 a.m., midnight. So if I wanted to use this at that date and time, I would just rotate this until June 3rd was lined up with midnight. So that's right there. And this tells me that for a person at or near 45 degrees north, at midnight on July 3rd, these are all the constellations that would be visible. So right here is directly overhead where the person would be standing. The pin is located at the North Pole, and you can see, you can see the Little Dipper right there. So north is in this direction. If you were to face northward, you'd be able to see all these stars. If you were to face south, you'd be able to see all these stars. West and east.
Well, everyone, you have been listening to the Allan I Carswell Observatory's weekly TeleTube broadcast, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Aria, John Luigi, Gagan, Quinton, and myself, Sana. Make sure to leave any comments in the comments section of this video. You can always connect with us on Twitter with the handle @YorkObservatory and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good night.